All right, number one. So as you can see, I've already gone ahead and solved every single question from this paper. And the point of this videos is to actually guide you guys through how I did each and every step. Okay, so let's have a look at the first question. Now, given that y equals 4x cubed minus 5 over x squared, where x doesn't equal 0 because it's a fraction, find in their simplest form dy over dx and the integral of y dx. Okay, so for the first one, this is just called differentiation at the first order. All you have to do is, before you even think about differentiating or integrating, rewrite the first equation in terms of the standard x to the power form. So looking at this one, we have 4x cubed, which is fine. However, we got 5 over x squared, and we have to realize that when you got x squared in the bottom, to bring on the baseline, we put a negative power. So this means the reciprocal. So x squared goes up and you write x to the negative squared. Okay? Now let's go ahead and differentiate. The rule of differentiation is that we always drop the power down. So in this case, we just drop the 3 down, so it'll be 4 times 3, which is 12, and then subtract the power by 1. And for the next one, we drop minus 2 down, so it'll be minus 2 times minus 5, which is plus 10. Subtract the power by 1, you get minus 3. Now be careful, guys, and then this is even for myself. Always never make sure you drop it down to minus 1, because that's not minusing, that's adding 1. Okay, that's usually a common error here. Now for part B, the integral of y, in other words, integrating this whole equation from the beginning with respect to x, all you have to do is simply raise the power by 1. So again, using this equation that we rewrote, adding 1 to the power 3, you get 4, and then you divide it by itself. For the next part, you add 1 to this power, so it becomes minus 1. Drop it down, so you're going to have 5 over minus 1. And one thing, never forget the plus c. Like, this is literally the most important thing, plus c. You actually gain 1 mark for writing that. And now all we do is just simplify the equation. The 4's cancel out, the minuses cancel out, you get a plus, and you're done. And that's it. You don't have to write it into its original form. You can leave it all in power form. And that's it. Let's go to number 2 now. So, question 2. Given that 3 to the power minus 1.5 is a root 3, find the exact value a. Now this is straightforward. All you do is make a the subject. So I just went ahead and divided root 3 across to something like this, and then putting this in your calculator, because remember, P1 you can actually use your calculator this time, unlike C1. And then you get 1 over 9. Now B, simplify fully. Now one thing to note is that this half here is actually a power, okay, so be careful, because I know it's quite big for a power. Now when you have something like this to power 3, this just means that you just attach the 3 to each of these terms. Because there's no plus minus terms, you don't have to worry too much. So in other words, the first one will be 2 to the power 3, and the next term will be x to the power half with 3, so half times 3. Straightforward. And then evaluating this in your calculator, you can just put 2 to the power 3 over 4. All of this bit will give us 2, and then you'll realize here that half times 3 will give us 3 over 2. And because you're dividing the terms, you subtract the power. So it'll be 3 over 2 minus 2, which will give us minus half. And that's it, guys. That's literally 2 done. Now, next question. So, number 3. Solve the simultaneous equations. All right, fair enough. For these kind of pairs, you'll realize you get a linear term here and then quadratic term. My tip is to always make, from the linear equation, the first one, y the subject or x subject. The reason why we should choose y this time, because if you look at the second part of the equation, you got 2 terms of x's, but only 1 term of y. It's better you make y the subject so you have less things to work with. Okay? Anyways, doing so, you just throw 4x plus 1 to the other side, so they become negative versions. And then substitute this one into y squared here, so you're going to get minus 4x minus 1 all to the power of 2, because it's squared. And then you copy out the rest of the equation like normal. Now be careful how you expand this one. Remember, this one means there's 2 brackets, so it's minus 4x minus 1 times minus 4x minus 1. So then you times every single term in that double bracket carefully to get 16x squared plus 8x plus 1. And then copy the rest of the term, and then collect in like terms to get these kind of terms. And then to make your life easy, you could use you could factorize, but I just put this straight into the quadratic formula because it's easy. So pick in your a, b, and c, which is 21, 10, and c, plug into the formula carefully, and then you should get these x values, which is minus 1 over 7 and minus 1 over 3. And then remember, for quadratic, for at least these simultaneous equations, you must also find the y values. And thankfully, from equation 1, you've already made a y equation. So just plug in these x values for the y equation here. So you get minus 4 times minus 1 over 7. Minus 1, you should get minus 3 over 7. And plug it over x value, you should get a third. And that's it, guys. That's literally 3 done as well. So, number 4. The straight line with equation y equals 4x plus c. So notice here that you have a gradient already with m equals 4. So here's a gradient of m equals 4. Where c is a constant, is a tangent to the curve of equation, this curve, y equals 2x squared plus 8x plus 3. So here's a quadratic. Okay. Now they want us to find the value of c. All right. Now, first thing you must spot this is that this equation here is just a straight line with a gradient of 4. And all they want you to do is find c. And because it's a tangent to a curve, it's always a good idea to try and visualize this. So because it's a quadratic, we know it's a U shape because it's a positive quadratic curve. And we've got a linear equation, so it hits that curve at some point. This is not exactly correct, by the way. This is just something I think it is. I know it's I know that the line's going upwards because it's a positive gradient. It means going up. But anyway, that's what you want. Now, all you have to really realize is that when you differentiate this equation, you can actually equate that to the gradient 4, because the dy over dx is known as the gradient equation. So differentiating this equation carefully, you drop the power down to get 4x, differentiate 8x, get 8, and 3 disappears. Equating that to 4, you can solve to find x. And of course, when you have an x coordinate, you might as well find a y coordinate. And to get y, I just plugged in x equals minus 1 into this curve here, and it gave me the y value. Now, to actually solve this equation, all you need to do now is realize you've got this equation. Let's go ahead and plug in the coordinates minus 1, minus 3 at this point. And doing so, you're going to get minus 3 here and minus 1 there. So it looks a bit like this over here. So minus 3 equals 4 times minus 1 plus c. Rearrange and solve for c, and you should get 1. And that's it, guys. You get y equals 4x plus 1. Oh, not bad. Not bad at all. So let's move on to number 5. So 5. So on the same axes, sketch the graphs of y equals x plus 2 and y equals x squared minus x minus 6. So it looks like you've got a linear term and a quadratic term. So that's why I put some steps over here. Showing the coordinates of all the points at which each graph crosses the coordinate axes. So we're not really concerned about when it hits. That's why I did this infinite dotted lines. You will in the next part though. So to sketch this carefully, my tip is to break it down into first the quadratic bit and then the linear bit. For the quadratic bit, it's always important to find out where it hits the axis, and to do so, you have to factorize the quadratic expression. So to factorize it, all we need to do is figure out two numbers that multiply to make this 6. And that is, of course, 1 and 6 or 3 and 2. And then using the same two numbers, we got plus and minus them to get a negative 1. Imagine this 1x minus x is minus 1x. And of course, 3 and 2 has a sum or difference of 1 or minus 1. And to get the same expression, it has to be minus 3 plus 2 will give us minus 1. So that's easy. And in doing this, you can clearly say that if it's x minus 3, then it must hit the x-axis at 3. And x plus 2 must hit x-axis at minus 2. So literally just flip the signs. Okay, and because we know it's quadratic, it's a U shape because it's positive. So just draw a U shape, cut out minus 2, and then cut that one at 3. And you know that it's going to hit at minus 6 on the y because we know that the y-intercept is over here, is minus 6. Another way to figure this out is literally just plug in x equals 0, because remember, it's on the y-axis. And if you're on the y-axis, x is 0. So if x was 0, y is minus 6. So that's done. The linear one's even easier. You literally just plug in where it hits the axis. So what I did here is I plugged in 0 for x, and I got 2. So our first coordinate is 0, 2, which is up here. And the second one is when I figure out where it hits when y is 0. That is x equals minus 2, which is over here. And then you just connect the line. So, and really, in reality, it's probably better if I drew this curve a bit, more dented inwards, so the line can actually hit this other side of the curve, because it will hit eventually. But yeah, let's look at B now and C. So on your sketch, show by shading the region R defined by these two inequalities. All right, so it looks like we got the same equations from part A. So we had this one and this quadratic, but now it's a less than and a greater version of the linear and quadratic. Now what you want to do here is, firstly, let's work with the linear term. My tip is to use the previous graph, so I copied it right here, by the way, guys, and I kind of dented it inwards to show that it hits. And all we want to do is literally do this condition. Draw the straight line across here and test the values on each of these planes and see where it's true. So I've decided, okay, let's test 0, 0, because we know it's below this blue line, and it's on this quadrant, it's on this side, on the bottom side. And when you plug in 0, 0, we find out that you get 0 is less than 2. And this is a true statement. And because it's true, this means that the inequality is actually going to be on this side. If I plugged in any values above over here, for example, let's pick something above. Like, let's say, I'm going to probably write this down. Let me just get my pen out. To the red. Suppose we chose a corner up here. So we could say that would be, let's say 5. So let's say that was 0, 5. If you plug into this equation, you're going to get 5 is less than 0 plus 2, which is 5 is less than 2. And this is clearly false. So this means this is wrong. So this side, so any corner you place on the above side is false. So that's why I put these X's, indicating that this side is completely false. Now let's look at the quadratic side, yeah? So I've done quite a bit over here. Using the quadratic term, this time you've got a few more things to do. I decided to work within the inside and the outside. So one thing to note, when you work within the curve, it will be the same answer. If you work in the outer part of the curve, it will always be the same as well. So for instance, I decided to try 0, 0 because it's in between the curve. And plugging 0, 0 into this quadratic equation, I did over here, turns out you get 0 is bigger than minus 6, with x is 0 and y is 0. And that is true. Because it's true, that means this is going to be the true reading. And therefore, the outside must be false. You can test it as well. I tested it to show you guys. When you plug in other coordinates, you get false. So then you just put x's on around it and make sure you shade in the middle and call it R. And that's it. Okay, part C. Now, hence or otherwise, find the set of values of x for which this equation is less than 0. Now, take a note. This equation here is not the same as these two. If anything, you can kind of see that it looks like the quadratic equation, but it's gone down by 2. And xy is gone down by 1. So actually it's x plus 2 into this one. This is a simultaneous equation. What happened here is that they used a quadratic equation and equated it to the linear equation. And then they subtracted x across and 2 across to get the same expression. And I'm guessing they did it in this format. Yeah, so that's what they did here. Now, the easiest way to do this is to factorize this equation or find the critical values. And just to look at this graph, you can kind of see where the set of values for where x is. It's talking about the range from here up to where it goes up to. But because we're looking at this point, we're trying to find up to here, what this coordinate is. Once you find that, you can find the exact range. So when you factorize this one, turns out you can get x is minus 4 or plus 2. So you get x equals 4, x equals negative 2, which makes sense because this is x equals minus 2. And x equals 4 is here. Then all you do is literally realize that it's within. And because it's within, it has to be the within interval. Alright, number 6. So we're given a quadratic looking curve, well, quadratic maybe, and it intersects at 2.06. Okay. It says the curve C passes through the origin and passes through 6, 0. The curve C has a minimum point 3 minus 1. So that's right at the bottom here. Now on separate diagrams, it wants us to sketch these two types of curves. Now let's look at part A for a second, y equals f2x. Now one thing to memorize is that when you're working inside the function where the x is, you're dealing with x coordinates. Another thing to note is that it works in reverse. So if it says 2x, you're actually halving the x coordinates. So copying out every single coordinates on this equation, we can say that 6, 0, halving the x will make it 3, 0. And as for the second one, 3 minus 1, half in the x coordinate to make it 1.5 minus 1. And you can kind of see that if you had to copy the sketch, this 6 has moved inwards halfway across to 3. So it's about here. And 3 has moved halfway to 1.5. So it's there. And of course, the origin 0, 0, when you half the x is still 0, 0. So that doesn't change. So it's going to be the same shape like this, still cutting through the origin. Okay, part B now. So we got to sketch y equals fx plus p. Okay. Now for this one, it gives you a constraint for p. It says that p is between 0 and 3. Another thing you need to note for these type of equations is that this is known as a translation. If you got x plus or minus, it means you're working with the x and then you're doing the reverse of its sign. Instead of adding p across, you're going to move p to the left. So you're subtracting p to every single x coordinate. So that's why if you're at 6 and you're minusing p, you're going to be at 6 minus p. If you're at 3 over here, you're going to minus 3 by p, so you'll be at 3 minus p. Again, if you're at the origin, you're going to go from 0 to 0 minus p, or just minus p. Now, that's what you have to do so far. Now, to sketch it accurately, this is why you have this interval for p. Because if you imagine it this way, suppose p was 3, even though it can't be, this means that 6 minus p will be 3, so it will be over here. But 3 minus 3 will be 0, so it will be at the origin. But it's not going to be, it's going to be less than 3, so it will be just between the origin and between where it used to be. So that's why you don't cut it through. You have to make sure it's just in front of the y-axis. And that's really it. You do not need to calculate the y-axis. So I was actually calculating it earlier, and I realized that this is actually a quadratic with x coordinates is 6 and 0. So it looks a bit like that. Expanding it, you get the same result. But again, you don't need to find y, so ignore this step. Just calculate it, just find the x coordinates, label it correctly, draw the right shape, and boom. That's easy 4 marks. So it states that a curve with equation y equals fx passes through the point 425. Okay, this is going to be valid for later on. Given that f prime x, so this is known as the first derivative, which over here you can say that f prime x is the same as dy over dx. And if they had a double prime or 2 primes, as in 2 apostrophes, it's a second derivative, and so on. Okay. Alright, so they give you something and we need to find fx. In other words, we need to go from f prime to regular f. So dy dx regular y. And to do that, we need to use integration. So on the next slide, I did it here. So always say this fact here. So f prime x to fx, you integrate. And integrating is, well, straightforward, thankfully. You look at each term, so let's look at the first one. 3 over 8 x squared. We look at x squared. Raise the power up by 1, so it'll be x cubed, and then divided by 3. So you can stick them together. You can say 3x cubed over 8 times 3. The next one, you're going to have 10x, add 1 to the power, so minus half. If you're not sure how to add 1, just put in your calculator, minus half plus 1, which gives you normal half, over itself, half. And then finally, 1 integrates to just x. Remember, this is the same as x to the power 0. X to the power 0. If you just want to see it clearly, it integrates to x, 1x to the power 1 over 1, which again is all just x. But to make your life easy, a constant becomes x, a constant 2 becomes 2x, and so on. And of course, don't forget plus c. Now, thankfully, because of our calculator, we can fully simplify this. So in your calculator, go ahead and write 3 over 8 times 3 and 10 over half to give you the simplified versions. Now, what do we do from here? So recall out how they told us that we need to use the point 425, because that's what this curve y equals fx passes through. Now the point of this is that this is not the final result. We need to evaluate c with the given conditions. So I said, okay, at 425, i.e. when x equals 4, y equals 25, we just plug into this equation. So fx becomes 25, and all these x's become 4. And then, as always, go ahead and simplify the right hand side. So all of this in your calculator becomes 8 minus 40 plus 4. Move it to the left hand side by minusing 8, plusing 4 and minusing 4. And you should get c equals 53. And then before you stop there and even put your pens down, make sure you write the complete answer. So go ahead and rewrite your original fx equation. Instead of c, make sure it is plus 53. And that's it, guys. Hope number 7 helped. And other than that, I shall see you lot in the next question. Ciao. So the line L1 shown in figure 2 has equation 2x plus 3y equals 26. So we can, of course, rearrange it into the standard y equals mx plus c later. Now, the line L2 passes through the origin and is also perpendicular to the line L1. What this means is that since we know the equation of L1, the gradient of L2 is just going to be the perpendicular gradient. So it's going to be the negative reciprocal of whatever the m value is for the first line. Now let's go ahead and find an equation for this line L2. Yeah. Now what I did, so I wrote L1 over here. I said, okay, let's rearrange into the y equals mx plus c form. And to do that, you need to subtract 2x and then divide it by 3. So it's going to look a bit like, let's see, this. Okay, so minus 2x divided by 3. Just separate them into two different fractions. So you get minus 2 over 3x and 26 over 3. So this means that the gradient for the line L1 is clearly minus 2 over 3 because of the m value here representing it. Now, thanks to the perpendicular laws, if you know one gradient, and that means a perpendicular one, it's just going to be is negative reciprocal. So this is minus, next one will be plus, 2/3 become 3 over 2. So now we already know what the m value is for our second line. So far up to this stage, y equals mx plus c, we got 3 over 2x. Now the y-intercept is easy. Just look at L2 and you can see it cuts through the origin. So it cuts at 0. And that means that your final equation is just going to be y equals 3 over 2x. That's it. Case closed. Now let's look at the next bit here, 3b, AB. So for this one, it says that the line L2 intersects L1. Okay, we just did that. Blah, blah. Okay, find the area of the triangle OBC. Give your answer in the form A over B, where A and B are integers to be found. Now, area of triangle OBC. So clearly, this is going to be from O to B to C. So we've got this little triangle here. So naturally, for any triangle, especially if it's in this form, you just need to work out what the height is and the width. If you can work out the height and the width, you can just plug into the area formula over here and you're done. So essentially, if we know the coordinates of B, we can work out its height. So you just need the y value. If you know the x coordinates C, you can work out its width from the origin. So let's go ahead and figure out what's B and C, yeah? So for B, I pretty much said, okay, at B, we can use the line L1. And since it hits the y-axis, this means that the x coordinate must be 0 because they ain't moving. So plug in x equals 0 into the y, into the L1 equation. We're going to get literally just 3y equals 26. And you're done. Just divide it by 3 and you got 26 over 3. So that is our y coordinate. And for C, well, you can see that the two lines intersect. Now, if two lines intersect, you pretty much just solve them simultaneously. So a bit like this. So we've got L2. Since the line of L2 is y equals 3 over 2x, you can substitute this into the first equation. So it looks a bit like this. Okay, just replace y 3x over 2. And now all you want to do is just solve this algebraically for x. And when you do that carefully, you should get x equals 4. Don't worry about the y here, guys, because all you really need to do is find the width, which is the x coordinate. So now we know the width. So the width is 4 and the height is what? 26 over 3. So plug into this area formula and you should get on the next page, next one, this. 4 times 26 over 3, all divided by 2. And just put in your calculator, comes down to 52 over 3. So let's have a look. So it states that we got a sketch of part of the curve C with the given equation. Okay. Now it says that the point A lies on C, so here's point A, and it's intersecting with the curve, and also B is also intersecting. And at point A, we know that the x coordinate is 2, so this point has an x coordinate of 2. Now, immediately before the question, if you know what the x coordinate is, you can find the y coordinate, given you have a y equation. So at point A, and because it's at the curve C, plug in the value of x equals 2 into the y equation. So when you do that, you're going to have 20 minus 4 times 2 minus 18 over 2. And doing so will result in y equals 3. So that's the trivial one, yeah? So that's the coordinates. Now, let's begin. Show that the equation of the normal 2c at A is given as follows. Now, this is a straight up line equation. And when you have something like this, normals and tangents, always start with y equals mx plus c. So let's go ahead and see how I did it. So what I did here, okay, to get the gradient in every single case, you need to firstly figure out the gradient equation. And to do so, we need to differentiate this curve equation, yep. And before you differentiate, we need to firstly make sure it's all written in the standard x to the power format, like this, yeah. So 18 over x has to be rewritten as 18 times x to the negative 1, because we have to bring x back to the baseline. And differentiating this is easy. So let's have a look. Differentiating 20 is a constant, you get 0. Differentiating minus 4x, you get just minus 4 because x vanishes. And for 18, x to the negative 1, drop negative 1 in front, so it'll be minus 1 times minus 18 is plus 18. Subtract minus 1 by 1, you get minus 2. And you found it. You found pretty much an expression for the gradient. Now, when you want to find the gradient at a specific point like A, and it tells you that you have an x coordinate of 2, plug in the x value 2, and then you have the gradient at point A. And now when you do that, what happens? Plugging in ax equals 2, you get half. So this would actually be the gradient of the tangent. But because we want the normal, which is this line, by this line is the normal, you need to find you need to pretty much do the negative reciprocal. So flip 1 over 2 to 2 over 1 and put a minus sign. So it becomes minus 2. So we're done so far. So we found the m value so far. So now we have y equals minus 2x plus c. So far so good. Now how to get c? Well, we know the coordinates, we know what the coordinate is at point A. So all you naturally do is just plug in the 2, 3 into this equation. So when x is 2, y is 3, and then so for c. And in doing so, solving for c, you're going to get 7. And that's it, guys. You got y equals minus 2x plus 7. So we've pretty much proven this bit. So let's look at part B, yeah? Now, question 9 continued. So the normal to C at A meets C again at point B. So we discussed this already. So you can see they're intersecting. Use algebra to find the coordinates of B. Now, this is either straightforward or isn't. And by the way, I'll put the line equation here. When two things are intersecting, we solve them simultaneously. So we have to simultaneously find the x and y coordinates with the line and the curve. So we have to make them equate, okay? That's when you intersect. And doing so, intersecting these two equations will actually make us get to this stage. Because they both equal y, you can essentially equate them together and then solve for x. Now this is the easy bit, guys, yeah? You just pretty much use algebra now. So the first thing you want to do is move everything to the left side. So I did that, so I added 2x across and minus 7 to get 13 and negative 2x. Then I realized, you know what, we got x at the bottom on a fraction. Nobody likes fractions. So let's go ahead and multiply x across. So you can get 13x, 2x squared, and then just 18. And then just, you know, you could work like this, but what I would do, I like to make my quadratics positive, yeah? So I move everything to the right side. So I get a positive 2x squared, negative 13x, and plus 18. And now, depending what method you want to use, I use the quadratic formula because it's quick and easy, no risk. And you get to use a calculator. So using quadratic formula where a is 2, b is minus 13, and c is 18, plugging in the necessary values, you should get an x value of 2, which represents the coordinate a, because of course it's intersecting, and another x value of 9 over 2, which must represent b, because 9 over 2 is what? 4.5, which is of course more to the right. So using 9 over 2, plug this x coordinate to any single equation. So you could have plugged it here or plugged on the line. I used the line and I got minus 2. And just to verify, I used a curve next and also got minus 2. So it says that the triangle XYZ, so this one over here, in figure 4 has lengths 6, 9, and 4 respectively, and an angle alpha and bang in the middle. The point W lies on the line, which is here. The circular arc ZW, which is this bit here, is a major arc of the circle. Okay, so this will be quite important. If this is an arc, there's a good implication that x is usually the center. Okay, and it tells us with center x and radius 4. So sometimes we look at this and it's very easy to forget where the radius is. Remember, the radius is always from the center of the circle to whatever, yeah? Any line from the center circle to the circle itself. So 6 is not a radius. 6 cuts past the circle. Only the first 4 centimeters is the radius, leaving this extra 2 centimeters to make up the rest of the 6. Anyway, let's have a look. So show that to 3 significant figures, alpha equals 2.2 radians. So we're looking at the angle here. And the easiest way to do this is to realize that we need to work with this triangle here and consider either the sine or cosine rule. So let's evaluate. If we're going to use it, so to use the sine rule, you need to work with 2 lengths and 2 angles. Well, we don't even have 1 angle, so sine rule is off the table, meaning we have to use the cosine rule. Now the cosine rule takes 2 forms. Either the a squared equals b squared plus c squared version, where you're trying to find the length, or in this case, because we're finding an angle, we should do the second one because the angle is the subject. Now as for the letters, because you only have a single angle, this makes alpha the default a. So this part here should be a. Okay, and yeah, we're going to select this one. So since alpha is a, that means that the length opposite capital A must be little a. So that means the length a would be 9, leaving b and c to be either 4 or 6. So b and c doesn't matter. Always remember that you always have to focus where the angle is. If the angle is A, the length opposite is A, and the B and C doesn't really matter. Anyway, it should look a bit like this. So b squared plus c squared minus a squared is 4 squared plus 6 squared minus 9 squared over 2 times 4 times 6. Easy stuff. And then of course a is cos alpha. Now all you want to do literally is firstly make sure your calculator is in radian mode, and then evaluate this, and then cos inverse, and then finally you get 2.22 radians. Easy stuff. So let's move on to B now, yeah? Now it tells us here that we need to find the area in centimeters squared of the major sector XZWX. In other words, this the whole area I'm shading right now. So this is the major sector. Now the only problem here is that the angle we calculate here is alpha, and when you work with a sector, you need to find the actual angle that's required. So we need to find angle inside. Now recall that the angle around a point must add up to 360 degrees, or in this case 2 pi, because 2 pi is 360. So if you know alpha, this must be alpha short of 2 pi, so 2 pi minus alpha. So that's what I call it, 2 pi minus alpha. And the area of the sectors is usually half r squared theta. So r is the radius, theta is just the angle you're working with. So in our case, this big angle we're working with is 2 pi minus alpha. So that's it, just plug it all in. So plug in the radius of 4, because we know the radius is 4, and the angle is 2 pi minus 2.22. I wouldn't bother evaluating it early. I would just put it all in the calculator once, just to get your answer. And doing so, you should get about 32.5. Easy. So let's move on to the next bit now, you guys. So what's the next one? 10. Area of the logo. So the region shows shown shaded in figure 4 is to be used as a design for the logo. Calculate the area of the logo. So the area of the logo, in other words, means it's a combination of the area of the triangle and also the area of the major sector. So in other words, that is what we're trying to work out, the sum of them. Now, first things first, let's look at the area of the triangle for a bit. When it comes to the area of the triangle, always use a generic formula, which is half AB sine C. Okay, visually that looks like this. So you need to find an angle. You need to make sure you have an angle between two known lengths. So if we just match this triangle to this triangle here, we can see that A is 4, B is 6, and angle C is alpha. And you just plug it in. So since you know all of this information, pop it in, and you're going to have half times 4 times 6 sine 2.22. Now I will just leave this for a second, because since you're going to add up the final answers, it's best you do this calculation all at once to get a clear, perfect, unrounded answer. Yeah. Now let's move on to the area sector. Well, as for the area sector, we already did it. This is a part B problem. We found that the major sector was about 32.5. So you could use this answer, but for the purpose of accuracy, I'm using the uncalculated answer. So I'm going to put this in my calculator, half times 4 squared, so on. And I'm going to add this to the area triangle version. And doing so will give us the area of the logo at around 42.1. If you use your 32.5, you should get about 42.05 ... which is still 42.1-ish. By the way, always try not to round any answers early. Always do it all at once, okay? That usually guarantees a higher accuracy. And you could you might lose a mark, so I can't really guarantee that. Anyway, guys, let's look at the final part, D. So this one wants us to find the perimeter of the logo, and to be honest, this is the easiest one, in my opinion. The only thing you may not have, firstly, is the arc length. And just a quick recap: perimeter is the length around the shape. So you're not looking through the dotted lines, okay? Always around the shape. We know firstly that we got a length here which is 9. We have a short length here which is meant to be 2, because we know that the radius is 4, and 4 plus 2 will give us the whole length 6. And then we also got the arc length, and now the arc length is defined as r theta, radius times the angle that it's reflecting. So the angle of interest would be this 2 pi minus alpha angle. So naturally it looks a bit like that, yeah? So you should write it firstly like this, label it 2, and then replace the arc length with radius 4 times 2 pi minus 2.22. So remember, that's the angle, this was this external angle, yeah? And that's it, guys. Just pop in the calculator and you should get about 27.3, and that's it. Done. Anyway, I hope this video helped, and It's covered every single thing you need to know. But yeah, I just want to say thanks for watching, guys, and if you enjoyed this video, give me a like, share, subscribe with your subscribe, and oh God, I'm getting so tired. And I shall see you next time. Ciao.